All right, today is October 25th. I'm back out here again. Going to work on setting the pinion depth. So this kit came in here. This is actually a ball joint kit, but I needed the spacers in them to press the bearing onto the pinion gear. So you can see how this fits down right there on the inner race of the bearing. That's what has to be pushed on. You can't push on the outside of the race because obviously it's going to, the cage, because it'll mess up the bearings and distort the bearing. And that would not be good. So what I'm going to do is set this thing up here in my hydraulic press I got from Harbor Freight and get ready to press this thing on. Here we go. All right, you can see I've got things set up here. I've got my spacer here, the bearing that's going on to the pinion. And I'm going to start pressing down right here. And I think I'm out of travel, so I'm going to have to readjust. I got things resituated here using one of my sockets. So I should have enough travel to take up the rest of that gap there. So here we go. Okay, I believe that's down. All right, I've got the bearing pressed onto the pinion, as you can see, and I've got my setup race. I just marked it with that red so I don't mistake it for anything else, although I shouldn't. As you recall from the previous video, ground this surface down. So the idea is so that the race can sit down in where the other one, where the permanent one will go, but I can take it in and out. You can see it down in there now. I can take it in and out, but what goes behind that is going to be a shim or a series of shims based on the pinion height, and there is a marking on this pinion here. And it says 2.551, sorry. So I think the original setting for the axle, pinion setup is 2.547. That's 4 thousandths different. That tells me that this is going to be further down into the differential, into the housing than the original one would be. But I don't know that for sure. It's really all going to come down to, what the gear tooth contact pattern is once it's all, put together. So, but for starters, what I'm going to do is put down a shim, I guess the original shim, or one close to it. And the pinion will sit down in there like that. Let me go ahead and get, sorry for the inconvenience of this, but... And basically, what I'm going to be doing is I'm going to make a jig now that I got off of another guy out of 1/2-inch plexiglass that's going to span this distance here and attach here with the cap bolts. And I'm going to be getting measurements down to this flat surface on the pinion to determine how far into the case it is. And I'm going to try to get this 2.551 because I think that is where they are suggesting that the height be. So I'm going to try to achieve that. Here we go. All right, I got this jig made, and I noticed that when I machined this piece here, the part that's, you know, kind of matted, you know, not totally clear like this, that there were some burrs up in here on this area. So what I did is I took a piece of 400 grit sandpaper on a machined surface, a table saw there, and I just, you know, worked it back and forth to try to work those down. So I've got a, you know, all over, of course, so that the entire surface is flattened, and that way I know that I'm going to get a good reading. So as you can kind of see peeking down through there, that's where the pinion gear is going to be, and this is going to allow me to use my dial or my caliper to get measurements on the depth of that pinion, because this surface is touching the bottom side of this surface, and this is, you know, the bottom side of the clear piece is sitting on the bearing, where the bearing caps go, which is the center line of the axle or ring gear. So this is really good idea that the gentleman had on You Can Do It too. Really good idea, and it didn't cost very much at all. I went ahead and got 2 pieces of this from Amazon for it was like 26 bucks. And that way, if the Dana 30 is different and I need to make another one, I'll have the piece I need. So, all right, I'm going to start with the shim that's the closest to the thickness of the original, and that's this one. This is a 0.104. So I'm going to set that down in there. And then the setup race will go down after it. And this is how it was set up in the factory. Put the seat down in there. All right, well, this is a 2-hand operation, so I'll get that set up. All right, the first step in this process, obviously, is to put your shim pack in behind the race that's behind the pinion gear here. Set the pinion in place, and then on the bottom side down here, you have to put the setup bearing, which is that small bearing that I took material off of the ID, so I can slip it off and on. Of course, the race is in there; it's permanently fixed in there, and behind the bearing will be the yoke. No crush sleeve or anything like that. The yoke, and then the nut. You have to take up all the slack there so that there's no end play in this. So you know the bearing or the pinion gear is seated all the way down in. And so now I'm ready to put my jig on there and take the measurement. Here we go. All right, so using my caliper here, I'm going to get 3 measurements and write those down associated with the shim that I have in there, which is a 0.104. And so I'm going to set this down like this, making sure I'm touching flat, and then go down to the top of the pinion on the flat surface. And I have 2.514. 2.514. No, 2.516. Okay, so I'm going to go write that down, and I'll be back. All right, I got 3 measurements here, and they are 2.516, 2.513, and 2.515, giving an average of 2.5146, or 2.515. So on the top of this pinion, on the flat surface, it says 2.551, and I called the Gear Squad at 4-Wheel Parts, where I got this pinion gear, ring gear, so forth, and the bearing kit. And the gentleman there, he and I both agree that we think that the 2.551 that's on the pinion face there is what G2 is suggesting as a pinion depth. So with what I have here and the shim that's in there of 0.104, doing the math, I'm still shy 36 thousandths and some change. So I'm going to stop here, go get my shims that I'm going to add to this, and see if I can get close to the measurement that G2 put on that pinion and see where we're at. There we go. All right, what I've come up with here is I've got a 31 thousandths and I've got a 7 thousandths, so that would be 38 thousandths. The calculation was 36 thousandths and some change, so let's just say 37. This gives me 38. So I ought to be very close with this, so I'm gonna get this installed and be back. Okay, I misspoke in the last clip there. My goal is the 2.551, I believe it is. Yes, 2.551, I don't know if you can see that. So I've got to have the pinion in there further away from the ring gear, which means I have to subtract 36 thousandths from the 104 that was there, and that gives me 68 thousandths, and I've got two 31s, that gives me 62, and then a 7, so that gives me 69. Is that right? Yeah. Gives me 69, so I've got maybe 1 thousandths more than I need, but we're going to see where this puts us, and then I'll be back. All right. All right, once again, I've got it set up. Let me get some measurements here. .556. All right, I'll get some more. I'll be right back. All right, so on that stack, I got a 2.552, 2.559, and 2.556, which averages to 2.555. The pinion head, or the surface of the pinion, says 2.551. That's a difference of 4 thousandths of an inch, which is basically about the thickness of a piece of paper. That's pretty darn close. I'm gonna call G2 to confirm that, but I think that's gonna be my starting point. I've got to wait for a inch-pound torque wrench to come today, or tomorrow, whichever day. I have an inch-pound torque converter, but it's inch-pound torque wrench, but it's a click type, and you really have to use a beam type when you're checking the preload on the bearing, on the drive shaft side, the yoke side of things. So I'm going to get this taken apart and give G2 a call, confirm that pinion number there, and that's probably going to be where I start. One thing I do know and it makes sense talking to the Gear Squad guy at 4 Wheel Parts, is I'm going from a 3:31 ratio to 4:10, so naturally the pinion gear is going to be smaller than the OEM pinion gear. And so that said, being smaller, it's going to have to move deeper into the ring gear in order to create the proper contact pattern. So this measurement here, actually, to me, yeah, it would actually put it further away than the factory one was. So I've got to call and find out what this number means and see what G2 recommends. But I think the standard measurement is 2.547. But I don't think that's going to work with all ring gear sets and pinion sets. So I'll do a little more digging and figure that out. So I think that's going to do it for today. We'll catch you guys next time. All right, I misspoke on the last segment there. I did want to go ahead and get these bearings on the carrier here. This is my Auburn Gear grip and lock. As you can see, I've already got the ring gear on, and those bolts are torqued to 70 foot-pounds. So I've got everything centered up here. I'm going to go ahead and get this bearing pressed on and then flip it over and do the other side. Here we go. believe that's seated. And again, a key thing there is using these, you're wanting to push down on the inner race of the bearing and not the cage itself. So, and that just happens to fit right over the shaft and the journal of this LSD. So, all right, I'm gonna go ahead and do the other side. Okay, I got both bearings on, pressed in, and what I've done here is I've set some shims down in there, you know, slid the whole carrier this way as far as it would go to create a gap, and then I pushed, you know, just tested different combinations of shims and pushed them down in there until I got a 0 end play here, which is what I'm wanting to start with. And at that point right there, that carrier is not moving at all. So I've got 0 end play. I've got quite a bit of backlash, which tells me that the pinion gear needs to come this way. But in any case, that's a good starting point, so I'm going to stop there. Okay, now that's with the carrier slid all the way over to the left, which creates the most backlash between the ring gear and the pinion gear. And I just wanted to show you this. You can see that gap is between the race and the housing. That's where I'm sliding in the shims. And looking at this shim pack, it's hard for me to do this holding the phone too. So I'm gonna put this down. Okay, looking at this shim pack, I'm measuring 151 thousandths. So that gives me 0 end play when I put that shim pack down in there, which consists of a 104, 31, and 2 8/1000ths, I believe. I'm gonna double check that, but I need to put that in my notes because that's my starting point. I'm probably gonna bring that pinion a little closer to the ring gear before I start checking the contact pattern. All right. All right, I had some more time I could work on this. I thought it had gotten later than it did, but I'm excited about what has happened here. Basically, what I did is I took the pinion out and I gave it a total of 151 thousandths, I believe it was. Yep. So, I'm sorry, that's the limited slip. The pinion, I gave a total of 101 thousandths, which is very close to the original shim thickness by 3 thousandths. So, I got that established, and then in order to get 0 end play, I had to use this combination of shims to come up with 151 thousandths. And then I noticed in doing that, after I installed the pinion and I put 15 inch-pounds on the nut on the yoke side, just to know that I don't have any, you know, I had to have some preload there, so that's why I did that. In doing that, I have way too much backlash with everything on the left side, or I'm sorry, on the right side, all of that. So I moved 47 thousandths of it to the left side and left the one shim that's 104 thousandths on the right side. And so what I mean is, on this side, on the right side, I've got 104 thousandths of shim right there on the back side of the bearing race. On this side, I have 47 thousandths of shim on the this side of the bearing race. And so now, with my dial indicator set up, let's see what I have here. Got to get zeroed out. Okay. I've got, as you can see there, about 8 thousandths of backlash. That's pretty good. I remember from my test engineer days that 6 to 8 thousandths on backlash is about what you want. Now, with a little bit more preload on that, when I put of course I'll be using the new race, which might have just a slight, you know, slightly bit more material there than the setup race, and that could account for maybe 1/1000th or something like that. But once I put more preload on this, somewhere in the order of 15 to 25 when it's all said and done, this measurement could change a little bit. It could go as much as maybe 9 or 10 thousandths, which I don't really want it to go on that side of the house. I'd rather it be, you know, more close to the 6 to begin with. So I'll probably play with this a little bit more tomorrow, but before I do that, I'm going to go ahead and paint these teeth and get a contact pattern first thing when I start working tomorrow. So anyway, it's exciting because this puts me about where I need to be. If I have a really good contact pattern on both the drive side and the coast side, that's gonna be real encouraging. So that's gonna do it for today. I'll catch you guys next time. Leave me a thumbs up if you like the content, and subscribe as well. Thank you. Bye-bye.